Hello and welcome. Today we are going to be working on question number 18 from our electronic homework. In this case, I'm going to entitle this one Follow the Energy, because the way we're going to solve this is by tracking the energy where it starts in the problem, how it transitions, and where it finishes and where it goes to. And so that will be our strategy for today. All right, so a spring has a spring constant of 150 newtons per meter. A block is pressed against it and compresses the spring. The block is then released and slides a distance before coming to rest. And the question is, how much friction is there between the block and the surface? All right, so let's start by just looking at where the energy is in each question. This is kind of the beginning of the question, scenario number 1. And what we have is we have the block pressed against the spring and compressing it. And while it's compressed, there is elastic potential energy stored in the spring. Okay, now since it's not elevated above a height and since it's not in motion, there's no GPE and there's no KE. So all the energy is in EPE. All the energy is EPE. And we actually have K and X, so we could calculate how much elastic potential energy is stored in that spring at this point. So we can actually calculate how much there is. After that, the block is released and it springs forward. Here it is blowing in the wind as it cruises across the surface to the right. And so at this point, all of the energy is in the form of kinetic energy. As it's moving. And now here and we'll call that situation 2. And then for stage 3 or situation 3, the block has slid along the surface, which was rough, and has come to rest. And so here's my question. Where did the energy go? Where did the energy go? Because in situation 1, stage 1 of the question, we have some stored energy. Stage 2, we actually have some kinetic energy, some energy that's visible as it's moving. And then at stage 3, the block's at rest. The spring is at a fully relaxed length. It's not compressed. And so where is the energy? There doesn't seem to be, the energy we had at the beginning doesn't seem to be there. It seems to have been lost. We know that energy is not destroyed, though. And so where did it go? And it turns out that this energy was used to do work against friction. So the energy was used to do work against friction. So if I were going to sort of make a flow chart of the energy, I would say that it starts as EPE and then transitions to KE and then transitions to work done against friction, at which point all the energy is lost to friction in the form of heat and is lost to the environment. All right, so the question is, what's the coefficient of friction for the block? All right, so we need to find, so we're looking for mu, the coefficient of friction. And you may remember from our previous chapters that mu is equal to FF divided by Fn. So we need to find FF and Fn. Now, if I could find the work done by friction, I know that the work done by friction is equal to the force of friction times the distance that it moves. And so I could find FF from there, and I could find Fn from the idea that Fn is equal to Fg, since this block is flat on the surface. So what we need to do is we need to find Fg, which will give us Fn, and then we need to find the work done by friction. How can we find the work done by friction? And that is going to be our elastic potential energy, which then all transforms and then is spent doing work against friction. And so if we know the EPE in stage 1, we can actually set that equal to the work done by friction. All right, so I'm going to clear the board, and then we'll get our work started. Let's see. There we go. All right. So let's see. First thing we want to do is find the EPE at stage 1. The EPE at stage 1. And that's equal to 1/2 times K times X squared. So EPE at point 1 is equal to 1/2 times 150 times 1.124 squared. Okay, and that's because it says that's the distance that it's compressed, and so that's what we can find. So take a moment and figure out the elastic potential energy. And I've calculated that to be 1.1532 joules. So 1.1532 joules. All right. So there's our elastic potential energy. Now, so that will be equal to 1.1532 is going to be equal to the work done by friction. So 1.1532 equals the force of friction times the distance that it travels. So 1.1532 is equal to FF times 0.274. So we'll divide both sides by 0.274, and we will get that the force of friction acting on the box is divided by 0.274, 4.208 or 4.209. Okay, so I've got 4.209 newtons for my force due to friction. All right, so I'll need to hang on to that number. Now let's find Fg. Fg equals m times g. In other words, it equals 3.12 times 9.81. And Fg equals 30.607. Right. So at this point, Fg is going to equal Fn, and we will have the value for Ff, and so we'll substitute those into mu equals Ff divided by Fn and get a value for that, and that will be our solution. All right, I hope that was helpful, and have a great day.